Assalamu alaikum wa rahmatullahi wa barakatuh. How are you all, student? Hope you all will be fine and studying well. So, your student, I welcome you all for our chemistry lecture, that is modern periodic table. This is our 8th lecture for the same. Till our previous lecture, we have completed the topics electronic configuration of elements in various periods and group. Today, inshallah, we are moving forward towards electronic configuration of elements in block. As we know, in the modern periodic table, there are 4 blocks. We have studied it earlier in detail. Which are that blocks? S block, P block, D block and F block. So here today we are going to study each and every block, all the 4 blocks that is, and how to write down the electronic configuration of element in these respective blocks. So your student, first block is your S block. Here the last electron in the S block element is filled in a S subshell. As we know, there are 4 subshells S, P, D and F. So whatever be the elements, whatever its atomic number, based on atomic number, we are writing down the electronic configuration. So whatever be the last electron, fine, whatever the last electron, here the last electron will enter in S subshell only. Fine. The last electron of any of the element who enter in the S subshell belongs to S block elements. There being only one orbital in a S subshell, as we know, in S subshell there is only one orbital and which can accommodate only 2 electrons. One orbital can accommodate only 2 electrons. These all things, shell, subshell, orbital, suborbital, we have studied in detail earlier. If you are having any query regarding it, see our previous lecture. Fine. What is shell, orbital, subshell, each and everything we have studied in detail. So here S subshell will contain only one orbital. So the general outer electronic configuration of S block element is NS1 to 2. Fine. NS1 to 2. So here, suppose here helium is there. Its atomic number is 2. Its electronic configuration will be NS2. Fine. If hydrogen is there, its atomic number is 1. Its electronic configuration is 1s1. If lithium is there, its atomic number is 3. Fine. Its electronic configuration will be N1s2 2s1. Fine. So based on its atomic number of S block element, it will contain the general outer electronic configuration will be NS1 to 2. N is the number of shell. 1 to 2, based on its atomic number, it will contain either 1 electron in S subshell or 2 electron in S subshell. Thus elements of the group 1 and group 2 belongs to the S block. As we know, there are 18 groups. Group 1 and group 2 elements will belongs to S block. And where it has been placed in the modern periodic table? Just imagine modern periodic table. The S block element is present on the extreme left of the modern periodic table. You see, imagine Modern periodic table. At the extreme left position, S block element is present. That is, your group 1 and group 2 belongs to S block element. So here student, we have completed S block elements. We are moving forward towards the second block, that is your P block element. Here similarly as in S block, the last electron will be filled in S subshell. Here the last electron of the P block element will fill in P subshell, where in last electron will enter in the P subshell. Fine. There being 3 degenerate p orbital in a p subshell. How many degenerate p orbital? 3. That is px, py, pz. And each orbital will contain 2 electrons. So how many degenerate p orbital is there? 3. So 3 to the 6. So it can accommodate 6 electrons. How many electrons it can accommodate? It can accommodate 6 electrons. The elements belonging to 6 groups are from group 13, group 14, 15, 16, 17 and 18. So these groups, group 13, 14, 15, 16 and 17 and 18 constitute the P block elements. And where it has been present? It has been present on the extreme right hand side in the modern periodic table. Where extreme right hand side in the modern periodic table, the P block ends with the group 18. P block ends with the group 18, which is a family of inert gases. As we know, group 18, they are known as inert gases, noble gases or zero group elements. So here, the first elements of the group 18, helium, does not have the p subshell, as its valence shell as n is equal to 1 subshell, and its electronic configuration is 1s2. There, according to S block element, the last electron will enter in the S. So here the last electron is being entering in S orbitals, but this helium, it is P block element. Why? The question is that according to the Obvi principle, we are writing down the electronic configuration of helium. Helium atomic number 2, its electronic configuration is 1s2. So according to the rule, the last electron enter in the S orbital. Yet it is not S block element. It is P block element. The reason behind it is helium is placed in the 18 group of the P block elements because its valence shell is completely filled. You see the last shell, that is your valence shell, it can accommodate only 2 electrons, and that 2 electron is being filled, which is a complete doublet. So here it is completely filled, valence shell is completely filled, and it is completely doublet, which is similar to complete valence shell of the other elements belonging to group 18. You see in group 18, neon, argon, krypton. As you move downside, you see all the elements of group 18 leaving behind helium. They have complete valence shell as that of helium, but it valence shells containing 8, that is 8 electron, that is they are completely octet, while helium they are having valence shell and it is complete doublet. So this, due to this similarity, helium has been placed in group 18 in P block elements. Find the general electronic configuration for the P block from the second to the seventh period. From second to the seventh period. Fine. P block element, second period to the seventh period. The general electronic configuration is NS2 NP126. Suppose NS2 NP1, NS2 NP2, NS2 NP3, NS2 NP4, and so on. So based on the electronic configuration, the general electronic configuration for the p block elements is NS2 NP1 to 6. Hope you all have understood this. Let's move forwards for D block elements. The D block elements in the modern periodic table is formed as a result of filling the last electron in d orbital. Here the last electron will enter in d orbital. A d subshell is present in the shell. Subshell will be present with n is less than or equal to 3. And according to n plus L rule, you have been studied chapter number 4. Right? As per the rule n plus L, this is present in chapter number 4. The energy of ns orbital is less than that of the n minus 1 d orbital. Suppose ns is 5s, n minus 1 d will be 5 minus 1 d, that will be 4d. Fine. The energy of 5s, I'm just giving an example, the energy of 5s orbital will be less than that of the 4d orbital. Fine. As a result, the last electron enter in n minus 1 d subshell. If the last electron will not enter in n d subshell, the last electron will enter in n minus 1 d subshell only. After the ns subshell is completely filled, the electron will move to n minus 1 d subshell only when the ns subshell is completely filled. There have been 5 orbital in a d subshell. How many orbital is being present? 5. And each orbital can accommodate 2 electrons. So in total 10 electron can be successively accommodated. Okay, how many electron can accommodate in d subshell? 10 electron can be accommodated. As we know, there are 10 groups, namely group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 in the d block. And where does it appear? It appears in the center of the modern periodic table. The general outer electronic configuration of the d blocks element is, remember, ns 0 to 2, n minus 1, d 1 to 10. Fine. Why I have given this ns 0 to 2? Why I have not written ns wow direct to? As it has been said, the ns shell will be completely filled, then only the electron will move in n minus 1 d orbital. Due to some variation in the configuration, it has been given the general outer electronic configuration of d block element is ns 0 to 2 n minus d 1 to 10. Because of the extra stability associated with half fill and a completely filled subshell. As we know that the half filled subshell and completely filled subshell are having extra stability. Fine. For example, here the example has been given. The outer electronic configuration of chromium atomic number 24, and its outer electronic configuration is 4s1 3d5. Here you see, as per Viii principle, the outer electronic configuration should be 4s2 3d4. But due to extra stability of half filled and completely filled subshell, here you see 4s2. For S subshell, the completely filled state is 2, but it containing 1. It means it is half filled. And 3D, for D subshell, the half fill is 5 electron and full completely filled is 10 electron. As in 3D4, it is neither completely filled nor half filled. Fine. So, due to the excess stability of half fill, the electrons from 4s will move to 3d. So 4s2 will be converted into 4s1 and 3d4 will be converted to 3d5. And due to this, both 4s and 3d subshell are half-fill and they will have associate with extra stability. Fine, due to this reason, some of the electron shows variation in the outer electronic configuration. Let's move forward towards the F block elements. In the F block elements, the last electron will enter in which orbital? Obviously, it will enter in F orbital. And we know there are 7 orbitals in F subshell. So these 7 orbitals will accommodate how many numbers of electrons? They will accommodate 14 electrons. 2 sevens are 14. So these 7 orbitals in a F subshell will accommodate 14 electrons. The general outer electronic configuration of the F block is ns2, n-1d 0 to 1, n-2f 1 to 14. Fine, this is the general outer electronic configuration of the F block elements. Here also the variation will be seen in the outer electronic configuration due to the extra stability of the half-fill and fully filled subshell, which should be need to be accounted. For example, the outer electronic configuration of europium, whose atomic number is 63, is 6s2 4f7 5d 0. Because the F4F subshell is, you see, it is half fill. Fine. It containing 7 electrons in 4F subshell, which is half fill. So here the F block constitute 2 series of 14 elements. You see at the bottom of the periodic table, 2 series is there, which is known as lanthanide and the actinide series. They are nothing but F block elements and they constitute of 14 elements. Put one below the other. First series is your lanthanide series, then the second below lanthanide it is your actinide series. Here the F block is placed separately. It has been separately placed at the bottom of the periodic table. Find these 2 series of F block elements, that is the lanthanide series and actinide series. They are placed separately at the bottom of the periodic table. Hope you all have understood it. Let's solve a numerical based on electronic configuration of the elements. Here the question is, outer electronic configuration of a few elements are given below. The elements with its atomic number and outer electronic configuration has been given. Explain them. We are supposed to explain it and identify, as well as we are supposed to find out the periods, groups and the block of these respective elements in the modern periodic table. And let's see the first elements. Helium 1s2. He, that is your helium. Its atomic number is 2. Its electronic configuration is 1s2. Here n, that is the number of shell, is 1. Therefore helium belongs to first period. Now see, the shell n is equal to 1 has only one subshell. Fine, namely 1s. As we know, the first shell containing only one subshell, 1s. The outer electronic configuration of helium is 1s2. You see, the maximum capacity for S subshell is 2. And here helium shows complete doublet. It is a completely doublet. Its valence shell is completely filled. So in group 18, I've explained it earlier, that group 18 elements valence shell is completely filled and they are completely octet. Due to the similarity of heliums and the other 18 groups elements, helium is placed at the end of the first period in the group 18. You see, it has not been placed in group 2. It has been placed in group 18 of the first period due to its characteristic of completely filled valence shell, that is a complete doublet. So here helium is placed at the end of the first period in the group 18 of inert gas. So what is its period? Its period is first period and it belongs to p block elements. Fine. Helium belongs to p block element. It is placed in first period and due to its complete valence shell, that is a complete doublet, it belongs to group 18, that is a p block elements. Now next one is your xenon, whose atomic number is 54 and its outer electronic configuration is 5s2 5p6. Here you see how many number of shell is present? 5. So n will be 5. Therefore xenons belongs to fifth period. Whatever be the number of shells, the elements will belong to that period. So here how many number of shell is there? 5. So xenons belongs to fifth period. And this outer electronic configuration is 5s2 5p6. So how many numbers of electron is present in outer electronic configuration? 2 plus 6, that is your 8. So its valence shell is completely filled, corresponds to complete octet. It has formed octet. Why? So xenon is placed in group 18. Group 18 elements leaving behind helium all are completely octet. So xenon is placed in group 18 and they belongs to, and group 18 is your p block elements. And therefore xenon is placed in group 18 and belongs to p block element. So here student, what is the period of xenons? Xenons belongs to fifth period. It belongs to which block? It belongs to p block. And what is it group? It belongs to group 18 element. Next one is your sulfur, whose atomic number is 16. Its outer electronic configuration is 3s2 3p4. Fine. So here students, say the outer electronic configuration. How many numbers of shell is present? 3. So it belongs to here. So here n will be 3 and it belongs to third period. You see here student, the 3p subshell is partially filled and short of completion of octet by 2 electron. Fine. Here it has not been completely filled, p subshell, 3p subshell, and it is lacking behind by 2 electron for the completion of octet. Therefore, we are doing for completion of octet, it means the elements belongs to 18 groups. So yes, it is lacking behind how many numbers of electron for completion of octet? 2. So we are subtracting 2 numbers of electron from 18. So 18 minus 2, it's belong to 16 group. It belongs to 16 groups. And as we know, the last electron enter in p subshell. Okay. And we know group 16 is your p block elements. So here sulfur belongs to third period as the number of shell is here is 3. And it belongs to group 16. How? 18 minus 2. because it is lacking by 2 electrons for completion of octet. So 18 minus 2, here it is 16. And the last electron enter in p or subshell, and this is 16 group elements. It belongs to p block element. The last one is your Au, that is your gold, whose atomic number is 79 and electronic configuration is 6s1 5d10. Here how many numbers of shell is present? 6. Don't see the last one, 5d. 5d is the inner subshell. The last subshell is your 6. Okay, therefore gold belongs to 6 period. Which period? 6 period. The 6th period begins with filling of electron in 6s and then into 5d orbital. As we have known, as we have studied, the 6th period begins with filling of electron into 6s, 1, 2, and then into 5d orbital. Here the outer configuration of Au has been given. It is 6s1 5d 10. Add the numbers of electrons. 1 plus 10, you are getting 11 electrons. So here 11 electrons are filled in the outer orbital of gold. How many electrons is been filled in the outer orbital of gold? It is 11. Therefore, gold belongs to group 11. As the last electron has entered in the d orbital, you see, the last electron, there it is entering in d orbital. So, Au, that is your gold, belongs to the d block element. So, here student, as per the outer electronic configuration, we have seen that 6 number of cells are present. So, Au belongs to 6 period. And the total numbers of electron in the outer electronic configuration of Au is 6s1 5d10, which implies that 11 electrons are filled in the outer orbital of Au. So, it belongs to group 11. And the last electron has entered in the orbital. So, it belongs to d block elements. Here we have completed. Hope you have understood. If you are having any query, any problem, revise the slide. Inshallah, you will be understood it well. Try more and more example. Till then, take care, study well, do your best. Allah Hafiz. Thank you, student.